Agile is different. So I'm going to do this in a really sort of abstract form at first. We're going to start with just going through the deployment or the creation of a website. 3 little features, and we're going to start the way that sort of everyone started, because computers were new and people were just trying to do stuff. Nowadays we call this sort of cowboy programming or ad hoc programming, but basically it was just programming. How do you make something? And so first we need a website, and the programmers would go, and they go to the computers and they'd code. And it didn't quite work the way that people wanted it, so they had to fix those bugs or those mistakes or those errors, and that cost money. In this case, it cost €1. So they go back and they fix that mistake, and they come back, and it doesn't really do what they want, and so they have to go back and fix it again, so we have another €1. And they keep going, and they go, and finally they get it so it works, which is fantastic. We have 3 things that we want to make in this website. So after we got the website, we also need a shopping cart. And this process sort of repeats. We do some code, it doesn't quite do what we want, it costs us some money to fix it, to do something else, doesn't quite do what we want. We fix the code, doesn't quite do what we want, we fix it, doesn't really do what we want, we fix it. Okay, we're almost there, we have a couple features that are missing, good. Now we have a product, we can ship it. We also have a recommendation engine, same process. Do some stuff, doesn't work. Do some stuff, doesn't work. Get it to finally a place where we're ready to release it. And the thing that was amazing about software is compared to almost every other industry out there, software is really cheap. So the companies that got through this process became very wealthy, very successful, right? But nonetheless, this is still a lot of money, right? If we look at this situation, they made 11 mistakes. It cost them €11. As long as you have €11, that's not a problem. But it becomes a bit of a problem if you have €10, right? So people start to look around and say, hey, you know, all these mistakes, they seem to be costing us a lot of money. Maybe we could make less mistakes. I said, maybe if we plan ahead and we know what we want to build, maybe we'll build the right thing. So Waterfall came about. Waterfall, you do some upfront design, you figure out what your customers want, and you go and you do the same thing, but now you know what you want. So you build your website. I mean, you almost know what you want. It's really, really close. Okay, we're there, right? So it's a lot better. We basically got it. Well, we have the shopping cart to do as well. Okay, I mean, the requirements are, there we are, good. And we know what we want from the recommendation. This is a little trickier because there's users, and users, sometimes they don't do what you expect them to do, but okay, good, we got it. So now we made less mistakes, 7 mistakes instead of 11 mistakes. It cost us less, success. And for a lot of the world, that's sort of where it stopped. Until sort of out of the corner, there started to come this development in the Agile world. And the Agile world said, you know, we're going to make mistakes. Maybe instead of putting this effort into not making mistakes, maybe we can make those mistakes cheaper. And so they have a website, and stuff goes wrong. But this time, it's only 5 cents. In fact, lots of stuff goes wrong, but we get there. And we get there quicker, and we get there cheaper. We have a shopping cart. And again, we're discovering a lot of stuff. Things are going wrong, but it's cheaper. It's cheaper when it goes wrong. We have a recommendation engine. Things are going wrong. More things are going wrong. But even though our number of mistakes is way up, 19, our cost is so low that if we made 1 mistake in the previous method, we're still better. So that we can sort of see the numbers. Waterfall, it makes us more right. But Agile, it makes our mistakes mean less. Now, it's a weird thing for programmers I'm a programmer, and being right means a lot to me. So it took some kind of hubris to let go of, to say, it's okay that I'm going to be wrong. Maybe I can work on accepting that I'm wrong and make it so that when it's wrong, it'll be okay. But the results were amazing, which is why a lot of Agile started permeating through the world, is people are like, how are you getting these results? Now, what are the practices? How do you make the cost of mistakes cheaper? It's not magic. In fact, there's 3 main tools that people use. First is detection. I do some volunteer work down in Zambia on a medical record project. I was out there for a month working with the team, doing basic stuff I do at regular companies, just for a company that would otherwise not be able to. And one of the friends that we were actually staying at her house, her mother came to visit. Her mother's older. She's, she can walk around and stuff, but she can't walk very far. So whenever we'd go traveling and stuff, she needed to bring a wheelchair. Now, when her mother left the house in Los Angeles to come to Zambia, she forgot her wheelchair. I don't know how you forget that, but you do. And had she realized that as she was leaving the house, it would have cost her an extra 5 minutes. Go back in, get your wheelchair, pack it up. She didn't realize it when she left the house. But when she got to the airport, if she had realized it there, even though it's the same mistake, now it would have cost her half an hour plus an extra taxi ride. She didn't realize it at the airport. She realized it when she arrived in Zambia and we said, where's your wheelchair? Where we could no longer rent a wheelchair, and it cost us $500 to buy a new wheelchair. Same mistake. If you detect it earlier, it will cost you less. Change. Sometimes detection's not enough. I had a friend, met a girl, got married, woke up the next day. Detection was immediate. But now change is a problem. So we need to make it so that when we realize something's wrong, it's easy to fix. That will make our mistakes cheaper. And then finally, there's area of effect. I was working with a client, and we were doing some stuff with the database. Development database, we're not in production or anything, but we messed it up. And me and it took us 40 minutes to figure out what we did wrong and fix it. And when we fixed it, I started to hear all these people around me say, oh, it's working now. And I looked at my pair, and I said, the development database that's everybody on the whole floor? And she's like, oh, yeah, yeah. So that wasn't 45 minutes of our time that we wasted. That was 45 minutes times 50 people's time. So you can do things to make it so that your mistakes don't take out other people. I could have made that mistake 50 times cheaper just by having a single instance of the database instead of one for the floor. These are our 3 main tools. And we're going to look at how they apply. And, almost everybody who's here, the way that we got smart is we made a lot of mistakes. So I'm going to take you through some of my mistakes. This is a fictionalized story, but loosely based on my history. This is the story of Acme. So at Acme, we got what I think is the best of all deals for programmers. We were hired by a company to develop a software system for them. And they gave us the rights to resell the system afterwards. Paid for the development, and you end up with a product that you can market afterwards. It's a really good deal. That's an amazing part of our industry. We were on the West Coast, they're on the East Coast. So we flew out to them, and we did requirements gathering. We talked to the users, we walked around shops, we figured out what they needed. Lots of meetings. And once we figured out everything that they wanted, they signed off on it, and we went back, and we started to build the system. In this case, it was a point-of-sale system. And we built it. It was a really small team at this point. It was just me and another guy, so 2 people. And we built it for about 4 months. And then we went, I'm sorry, I had that wrong. They came to us and to demo the product. And we're demoing the product, and we're really happy with it. They're really happy with it. The meeting is going particularly well. Until this one part where the guy said, how does it handle purchase orders? Now, in a point-of-sale system, there's a lot more complexity as soon as you start to involve credit and history. It's much easier if everything's cash up front. And we said that. We said, it doesn't handle purchase orders. We've talked to you about this. And you told us that you never do purchase orders. You always do cash up front. And the guy, in a way that only non-programmers can do, with the sincerity, said, yeah, we never do purchase orders, only once or twice a year. But they're really big accounts with the military. We need to handle this. And we tried to explain to the guy that never and once and twice a year are not the same things at all. And the meeting started going very badly. But fortunately, we had a sales guy. And the sales guy knew exactly what to do to solve the whole problem. He looked the customer straight in the face and he said, don't worry, we'll take care of it. And so we went back, and we basically had to start over. So let's talk about the mistake. Well, first of all, what would that have looked like if we didn't make a mistake? The customer would have come in, he would have been happy, he would have left, life is great. The problem, of course, is the customer isn't happy. And the reason he isn't happy is because we misunderstood the requirement. Now, as I told you before, Agile isn't about not making mistakes. Agile isn't about how do I not misunderstand requirements. Agile is about accepting that you're going to make mistakes. You are going to misunderstand requirements. So given that I'm going to misunderstand a requirement, how can I make it cheaper? Which of these tools can I use? And I think the answer is detection. This is where we did the demo. This is where we got the requirements. So this is about 4 months. Had we done it in about 3 months, that would have been cheaper. We would have thrown away 3 months of work. If we had done it 2 months, that would have been cheaper. We would have thrown away 2 months of work. If we had done it 1 month, that would have been cheaper. Is there a lot of turning up the dials to 11? That's where it's the cheapest. And the way you do that is a practice called on-site customer. It is all about detection. And in the best of situations, it's an actual customer on site. This is a very possible thing in a lot of industries. In some industries, it's not possible. So you have sort of a customer that's highly available. I want to make sure that I'm clear. It's not a business analyst. It's not the same thing as an on-site customer. They're important. Business analysts can help your on-site customers understand what they want. They can help translate, but you need an actual customer. Someone who has skin in the game, someone who has to actually use the product. It makes a big difference. So we went back and we started to redo the code. A little bit more complex now. A lot more has to be tracked and managed. We brought in a DBA to sort of handle a lot of that storage and structure and querying. We're building it. Our team's a little bit bigger at this point. I think we're up to 4 people. But we're on track. And again, the people at their company who make these things, they price more than enough that we can handle this kind of stuff. So we're still profitable, we're still good. And we're ready. We're ready for the second demo. I should probably talk about our DBA, Tom. Tom is a good guy. He's a friend. Really, really stellar DBA. He was on the geekier side of the spectrum, which had some personal issues for him as a general rule. But right before our demo, he met a girl who was fantastic, and they got along like crazy. And Tom decided he was going to get married, which is great for Tom. We had a demo that didn't work so well with Tom going to Vegas. So we tried to explain to Tom that maybe he could get married later. But Tom wasn't interested in our demo. Tom was interested in getting married. So we threatened Tom that if you leave, we'll have to fire you. But Tom wasn't interested in that either. So he left, and he went and got married. The whole thing is that the product doesn't work without a database, like at all. So we're now like dead in the water. So we went to our network and we really quickly found a really good DBA at a fairly high rate, and we brought him in. And he knew exactly what to do, but he didn't know how everything worked. He didn't know which databases were the real ones and which ones were production. He didn't know where passwords were. He didn't know which scripts were the good scripts and which scripts were the bad scripts. And it takes time to figure out how the thing actually works. Time that started to creep on our calendar very, very quickly as a week and a half turned into a week, turned into 3 days, turned into 2 days, turned into me making a phone call telling the customer not to get on the plane. There's no point in them flying across the country to see something that we couldn't demo. That was a horrible phone call to make. Believe me when I say if I had any other choice, I would not have made it. So what's the mistake? What would that have looked like if everything had gone right? Well, possibly, Tom wouldn't have decided to get married that day. That would have been great. Or possibly, when the new guy came in, he could have just kept going. Or possibly, we wouldn't have even needed a new guy. Tom could have just gone and got married. As I said before, Agile is about accepting that you're going to make mistakes. It's not about preventing them. Agile is not going to stop you from falling in love. But it will make it cheaper when you do. Our problem here is that we had one guy who knew everything. When he disappeared, we were dead in the water. There's different terms for this you'll hear. Hit by bus is a really common one. Google has the phrase, we're tired of wealthy. So let's go to our toolbox. How do we get rid of this? Would detection help us? Not so much. We knew about Tom falling in love right away. He was very vocal about it. Change would have been nice. If we could have swapped Tom out, that would have been good. Now, this is a weird thing. Almost every company I work at backs up their data. They understand that disks fail, and it's good to have a backup of it. They value that. They also value their employee knowledge, but they don't seem to have any concept of backing that up. So the way you back that up is a practice called pair programming. You'll also hear mobbing. There was a talk about that earlier or later today. Pair programming has a lot of advantages, but I don't want to talk about most of them. I want to talk just right now about the backing up of knowledge. Having it so that when an employee leaves, actually permanently or just on vacation or just happens to be sick that week, it's not a big deal. That knowledge is still there. Pair programming is a really simple practice. 2 people at one computer, working together. The rule I usually use is to go from one person's head to the keyboard or to the computer, it goes through someone else's hands. And if we had done that with Tom, not only, even if we had done it just with someone who wasn't even a good DBA, wasn't even a DBA, we could, when we brought in the new DBA, the other guy would have known where the scripts are. They would have known what the passwords were. They would have known where the servers are. He would have known enough to enable somebody with skills that might take longer to develop. There's one thing I want to point out. There's a lot of really good stuff here in the pair programming illuminated by Lori. She goes through a lot of studies they did in terms of speed, because that's one of the first complaints about pair programming is everyone's like, I'm paying 2 people to do one person's jobs. But the studies show that if you have one person, they do 40 hours worth of work in a week, and if you have 2 people, they do 80 hours of work in a week, and if you pair them, you get 80 hours of work in the week. It's a kind of tricky formula, but it turns out that you don't lose any velocity, you don't gain any velocity, you do have a lot less bugs. It's different depending on how you're measuring. So, anyhow, we have the new DBA now. He does eventually get everything to work. Things are going pretty good. And our team is bigger, which makes my manager happier. Bigger teams, more important, right? And there's a conference. There's a conference called Mix out in Vegas, put on by Microsoft. We were a Microsoft shop. And they introduced the Windows Phone. It was kind of neat, right? Because the iPhone had been out. Everyone loves the iPhone. Android came out. This was billed as a phone for business. And they did this demo on the stage where they had a WPF app, which is like a standard Windows app. And right there on stage, they changed it so it worked on the phone as well. It was awesome. A very, very nicely done demo. And of course, a lot of the world was watching this, including our customer. And the blogs talked about it. And the very next day, our customer called our salesperson, who he tends to like to talk to more than us, and said, "This is great. We need it on our phones." And our sales guy agreed. And so we decided, we're going to make this work on the phones too. And the thing about the demo on stage is it wasn't exactly a lie, but let's just say the code they were using was very well suited to move to both platforms. Our code was uglier. Well, first of all, I don't know if you know this, but a lot of times programmers will choose our technologies based on what we think is exciting as opposed to what we know very well. So there was a bit of learning as we go on this project. And then, of course, it kept changing, right? We had to rewrite and change new features, and so the classes kept growing and they got uglier. And the separation that was in that demo was not in our code at all. So what we started to do is it would pull the code apart. And that kind of stopped it from compiling for a little bit, and then a little bit turned into a couple of weeks. But eventually we got it compiling again. It wasn't working as well, but that's okay. We brought in some people who were good on the phone side, and we kept the people who were good on the WPF, and then we sort of added a new group that was sort of the back end to sort of manage the thing, right? So we had our 3 teams, and eventually it started compiling again. So again, what was the mistake? Well, what would it have looked like if it didn't go wrong? It would have looked like that demo. 1 hour later, everything's happy. And for that to happen, our code needed to be easy to change. We need to know that the requirements are going to change. There's no way to know that a company is going to release a new technology short of industrial sabotage. So, changing requirements. Requirements are going to change. Accept that. What can our toolbox help us with? Well, in this case, detection doesn't help at all because the whole world knew about this because it's that demo. In this case, the change would have helped a lot. If our code was easy to change, then we could have responded when requirements changed. And this is a practice called refactoring. I think this is maybe one of the most misunderstood of the Agile practices because I think everybody thinks they do refactoring. So sometimes it's referred to as merciless refactoring. Ward Cunningham described it as the instant you have an insight into how your code should have been written, you change it so it looks like you knew what you were doing all the time. These are not rewrites. These are not big things. These are a lot of very small things, 2-minute things. And if you don't already know the shortcuts in your editor to do them for you, start there. Right? Start by learning the shortcuts. So as I said, we got the code split up. We got our 3 teams now, and we're almost done. Project is finally done. It's a lot longer than we originally spec'd, but we're still like right on the edge, right, of good money. We're still profitable. We're not very profitable. We have this whole revenue stream that comes in once we deploy to this customer. We can start selling to other customers. So things are good. I know we're at the end because we're using Microsoft Project, and Microsoft Project tells you how far along you are as you go, and we're at 95% done. So it's like 2 more weeks, and we're done. And all we had to do in these 2 weeks basically is take the 3 groups that have now been created, the phone, the Windows platform, and the back end, and just get them to talk to each other, just connect them up. Snapping together, like Legos or your TV, it's easy to do. Except for, like on my TV, right, I have these 3 cords, so it's like yellow, green, or yellow, white, and red, and they snap into 3 holes. They're yellow, white, and red. And it wasn't quite like that. Like here we had 20 things that needed to get done, and one part had 5 ways of doing it, and the other part had 4 different ways of doing it, and neither side could really change. Both sides said the other side was the problem. And that last 5%, that ended up taking almost as long as the rest. It took us 4 months. And during this time, I would complain to my friends, right, because I was very stressed out at work at this point, and they would laugh at me, and they said, "Didn't anybody tell you the last 5% takes just as long?" I was young and naive, but also I was kind of upset that, like, why is Microsoft Project lying to me? Like, why does that progress bar just not go slowly through? So what's the mistake here? What would it look like if it was good? Well, it would have looked like my TV. I would have just snapped the stuff together and would have taken the 5% that was promised in my flowcharts. And we call this integration. Integration did not go well. So I got my toolkit. What should we look at? We sort of have 2 things here that would have been nice. One, detection. It would have been nice at the very least if I had known I wasn't 5% away and I could have managed expectations. But also it's easier, right? Because there's a lot of development that gets done on top of it. So the area of effect becomes a big part here. When I had these problems, I couldn't just change one group. I had to get 3 groups to change together. Turns out it's very hard to change 3 groups together. So the practice for this is called continuous integration. It's a lot about detection, but it's also area of effect. And if you think of even the most basic concept of continuous integration over, say, a nightly build, if you have 5 programmers on your team and they all commit code during the day and the nightly build breaks, there's a lot of finger pointing of who broke that build. But if your build occurs after each check-in and it was working before Sam checked it in and it's not working after Sam checked it in, then it's Sam. I want to talk about killing the messenger. This is something I see a lot, where I go to companies and I say, "Hey, do you have CI?" And they're like, "Oh, yeah." I'm like, "Oh, great. Is it running your test?" And they're like, "Well, they used to fail a lot, so we turned them off." I don't know why I see that a lot, but I do see it a lot. Turning off your tests doesn't make your software work better. It just makes the build pass. All right, so we did finally get everything to connect up and start working together. And we're now ready to go to production. The only thing we have to do before we go to production is a QA process. We need to take it through and make sure we don't have any bugs. And so we send it to our testers, and they bang on it, and they come back. We are so awesome. They found 10 bugs. We had been working on this project almost a full year, 10 bugs. It's amazing. We celebrated, we go out drinking. 10 bugs is nothing. We banged that out in like less than a week. We sent it back to QA, and they came back with 5 bugs. Some of the things they couldn't get to because the other bugs, 10 bugs is nothing, 5 bugs is less than nothing. So that's fine. We spend another, about a week, and we fix that up and we send it back to QA. And they came back with 6 bugs this time. That's weird, but again, there's these areas that don't. But it's not a problem. 6 bugs is still less than nothing. We spend another week, and we solve those 6 bugs, and we send it back to QA. And they came back with 4 bugs, which is less than any of the other bugs. It's basically nothing. We're done at the end of the week. Except for this time when we told our boss that we're done at the end of the week, being 4 weeks of being done at the end of the week, he rolled his eyes a little bit at us. But it doesn't matter. 4 bugs is nothing. We fix those 4 bugs. We send it back to QA. Came back with another 5 bugs. But again, this is so nothing. So we fixed those bugs out. We're still drinking, by the way, at this point. When we got to the 2-month part, our customers just at that point lost trust in us. We were still just a week away, though. We still had less than 10 bugs. We never had more than 10 bugs. When we got to 3 months, we started to lose some of our better programmers who found more interesting stuff, usually in the same company, but not always. It was about 3.5 months when we finally got done with the 10 bugs and got to production. There's actually a term for this, 6 bugs away for production for 6 months. All right, it's an unfortunately common case. So what's a mistake? What would this look like if it went well? Well, instead of constantly having bugs, we wouldn't have bugs. Our mistake was bugs. So, how can we fix this? What makes bugs cheaper? Not you're going to have bugs, right? How do we not have bugs? How do we make those bugs cheaper? And in this case, we're back to our friend detection. Now, let's say this is the start of my day. Let's say this is 8 o'clock in the morning. That's a lie. Let's say this is 10 o'clock in the morning. And I program all day. And I'm a super good programmer, so I only make 1 mistake all day. And then it's going to take a little while before this gets put into the deploy and shipped to QA. Right? How can I make this cheaper? Well, the obvious thing, of course, is I could move QA right here to the end of my code. This is a technique we usually see as test after. But of course, where it would be the cheapest is if I could get it right here. Now, to get it right here, the test needs to occur right here. This is a process called test-driven development. It is so much about detection, and it is so different than test after, although that also has benefits. I want to take you through a really quick example of this, because a lot of times the speed of it is confusing to people. So this is about how long it takes. First, I need a scenario. So in this scenario, we're making an order. I want to buy 10 shirts at 100 euros each, and I have a sales tax. I'm just going to set it to 10% because that's easy math for me to do. And then I need to verify the total of the order. That's about how long it should take you to write out a scenario. You're going to write these out very frequently in little steps. Okay? So now I need to turn this into code. New order is basically new order. It'd be really nice to have a method called add item that took what I was adding, the amount and the price. It'd be great if I had a way I could just say sales tax is 10%, and it'd be useful then to check that the total was 1,100. And I can do all this because no code exists right now. This does not even compile. I am very free to design my code the way it is easy to use. And that process that we just walked through, write it in English, write it in code, delete the English. Usually takes about 30 seconds to 45 seconds for someone who's fluent in test-driven development. This is one of the things I teach. It usually takes new people about 15 minutes to do that. It's not that it's hard, there's just a fluency issue. So keep in mind when your people start test-driven development, it's going to take some time, not to know what to do, but just to get fluent at it. I mentioned before, we made it through. We got the bugs solved. It's not exactly all the bugs, but let's say all the bugs we really cared about got solved. And now we can ship it to the users. And they can start using it. And our software did all the requirements, everything that was needed to make the system work. It didn't always do them in the nicest ways for the users, so we needed some training. But that's okay. We created some training, we went out, we trained the users, they started to use it. They still didn't really like our software. In fact, some of them really didn't like our software. We heard one store went back to paper. But whatever, they paid for the software, they got the software. But the problem became that this project had a lot more people and took a lot more time than we originally estimated that it would. So much so that we are now sort of losing money on the project, so it was really important that we sold new versions to other customers. Right? And we got, marketing got a good quote from the other things, but the problem wasn't the quote, the problem was that the people at the company talk, and they talk to other customers, and other customers kind of knew this was not a good product to buy. And it made it very hard for our salespeople to sell new instances of this product. But they're diligent and they tried, but after 2 or 3 months, we finally just shut the whole thing down. And that ends the story of FME. So what went wrong there? Well, what would it have looked like if it didn't go wrong? We would have had happy customers and new customers lining out the door. We built something people didn't want. So we look at our toolbox again. How could we have made it, again, not that we didn't build the wrong thing, but the things that we build wrong don't matter so much. In this case, detection is our tool again. And the practice is iterative development. By the way, most of Scrum comes down to this practice, right? There's a lot that comes from iterative development. It's a really good place to start. I want to point out that iterative development kind of sounds like the first thing we did, that on-site customer, but there's a really, really key difference, and it's deploying. On-site customer, you're talking to the customer, you're showing them demos. It's not the same as deploying. And there are historically bad situations where people confuse the two, and the biggest one that I know about is Coke. So Coke, not Coke, actually Pepsi. Pepsi did this thing in the 80s called the Pepsi Challenge, where you did a sip. You took a sip of 2 sodas and you had to decide which one you like. And overwhelmingly, Pepsi was winning, which scared Coke. Coke ran the test themselves. The tests were right. If you take a sip of Pepsi and a sip of Coke, most people prefer Pepsi. It's sweeter. In a sip test, sweetness wins. But the thing is, you don't take a sip of your drink with dinner, you drink the whole thing, and over the whole course of a glass, Coke is preferred. Coke didn't run that test. Coke only did the sip test. So they decided to create New Coke. New Coke was a disastrously bad idea. Until the customers are living with it, using it, you will judge on the wrong things. It's the difference between taking a car at a test drive and once you actually own the car. Right? You need to get it deployed. It doesn't count if it's not deployed. You're going to get different feedback. And when you get that different feedback, there's two things you can do. One thing you can do is you can fail. Sounds like a weird thing to be happy about, but it's something we talk about a lot in Agile, failing fast. Failing fast can take a project that is going to cost you millions and millions of dollars and make it only cost tens of thousands of dollars. And in a weird way, that's a win. There are projects that deserve to die early. But they don't have to. There's another thing you can do with this, and that's you can steer the project. I'm going to give you two quick examples of what it looks like to steer. First, just on stage here. Let's say that I want to get to my computer. It's a fair way away. I can sort of look into the future and say, my computer is here. I can aim myself so that I'm going straight to the computer, and then I can walk. And I cannot get to my computer. It turns out it's very hard to aim far into the future, which is how a lot of companies do it. Way back 5 years ago, we got our requirements we're all about to release. For some reason, people don't seem happy. So steering looks like this. It's a lot less precise. Computer's sort of over here. Take a few steps and then say, okay, now it's more to your right. Take a few steps. Okay, now it's more to your left. Take a few steps. Now it's more to your right. Take a few steps. Now it's more to your left. Get to your computer. That's steering. Iterative development allows you to do it. It allows you to change your mind. It allows you to respond. Here's another example. This is what it looks like a little bit more, less abstractly, but still abstract. So we have some requirements. I need 2 circles in the center. I need a line at the bottom. I need a rectangle around everything. First, I have the conversation with the customer where I explain that we need to choose part of this. What is the most important? And then they have the conversation where they tell me everything is the most important, and then we have the conversation again. And I'll say something like, hey, maybe we can do the 2 circles in the center. And they say, that doesn't even make any sense. There's no center until we put the rectangle around. And I say, okay, well, let's do a rectangle. So we do. And now they get to use it. And they say, this rectangle, it's a little hard. Can you change it? And you know what? We just wrote it. It's not that connected to stuff. It's easy to change. Let's soften it up a little bit. And then they say, yeah, I kind of like that. I'm like, oh, what do you need now? Oh, we need that circle. Okay, we got 2 circles right there in the center. That doesn't quite work. Maybe you can lift them, separate them a little bit. Okay, we can do that. What about that line? Yeah, let's do that. No, it needs to curve. Oh, we can, the other way. So the thing is, both of these things satisfy the requirement document. But one is a product that your customers want. And that's the effect of steering. So again, we just really quickly touched on 6 of the technical practices: on-site customer, pair programming, refactoring, continuous integration, test-driven development, and iterative development. There's so much more to go into with all of these, but if you use that guiding principle, accept that people are going to make mistakes. Just accept it, and put disciplines and practices in place to make those mistakes cheaper. And that will guide you for a very, very long time. Thank you very much. So I'm at the end of time, so there's no time for questions, but I'll be over in the coaching area, and I'm happy to talk to you guys as much as you like.